Okay, so here's the second of two videos that I have to show you screencasts of my lessons on titration. So this will give us more time to kind of play with when we do get back to class. Let me just kind of go over the basics of titration again. So titration, remember, involves using a burette to find out the concentration of some kind of substance. In our case, it'll be an acid that we're looking to find out its concentration, and so that we call the titrand, and the base that we're using, and we know its concentration, is called the titrant. So titration was performed using 25 milliliters of acid as a titrand. So down here it means that I've measured out 25 milliliters of acid, and that's a piece of quantitative data that I will use in my calculation. Sodium hydroxide was chosen as my titrant. So I use sodium hydroxide here. So this burette is filled with sodium hydroxide. I'm going to say this is hydrochloric acid. So envision yourself having done the titration, and when you see that color change, that end point is at a point in the titration where you've added 9.7 milliliters of your base. So 9.7 milliliters of that base, and you know its concentration. So these are two valuable pieces of quantitative information that we're going to use in order to calculate the concentration of our acid. And so the first thing that I want to do, this should actually be step one up here, is I write out the reaction equation. So I have my acid, HCl, and my base, sodium hydroxide. And I'm reacting the two of them in a neutralization reaction. I'm going to write out my products. Now sometimes I will need to balance my chemical equation. In this case, it's already balanced for me, so there's no other work to do in that respect. So I've written out what I know here just to kind of keep it in mind. I know that I have, my base has a concentration of 0.10 moles per liter, and I know that I had to add 9.7 milliliters of my base in order to neutralize the solution and reach my endpoint. So 25 milliliters of my acid are what I started with, and the whole point of this titration is to figure out the concentration of my acid. So the first thing I'm going to do is I'm going to work out what I can for now, right? Which is to find out the moles of my known solution. In this case, this is the base, based on the data that I have. Well, I know how many milliliters of base I added, and I know the concentration that I added, and so that will allow me to figure out the number of moles of base that I used. Okay, so in order to find out the moles of our known solution, I'm going to use this formula, which you hopefully remember from earlier in this unit. So concentration is equal to the number of moles divided by the volume. So in order for my units to cancel appropriately, I need to make sure that all of my units have been converted properly. So I know that concentration is measured in moles per liter, and moles are measured in moles. And so my volume needs to be in liters in order to have my units cancel appropriately and to get the correct answer. So I'm going to utilize the information that I know, substitute it into this formula, and then solve for my number of moles. So substituting in my 0.10 moles per liter and my 9.7 milliliters converted to liters. I now can isolate my N here. And look, so if I even just put my units in, we can see that cancellation happen, right? So I have liters up here divided by liters, so my liters will cancel out. I'm left with units of moles. That works because that is the value that I'm looking for. That's the dimension I'm looking for. Okay, so using either mental math or using your calculator, I can calculate that the number of moles that of base that I needed for neutralization to take place was 0.00097, and if you prefer to write that in scientific notation, that would be even better. So now that I have the number of moles of my base, I know that really this chemical reaction is written in proportion, right? And that the coefficients of the balanced equations indicate the ratio of moles of each substance that are required in the reaction. So if I know that I used 9.7 times 10 to the negative 4 moles of my base, in this case my 1-to-1 ratio tells me that this 9.7 times 10 to the negative 4 moles of base is also the same number of moles of acid that ideally I have if I have in fact neutralized my acid. So again, I'm going to use a mole ratio the same way as we did in our stoichiometry unit to find out the number of moles of acid that were neutralized. And so in this case, it's a 1-to-1 ratio, the moles of each of them. Really, I should be looking at my moles of H plus versus my moles of OH minus, because those are what are being neutralized. Now we have our final step. We're almost done. So the last and final thing to do is to determine the concentration of the acid. Remember, the whole point of this exercise was to determine its concentration. We don't know what it is. So we're going to use the same formula as we have used already in this calculation, which is C equals N over V. But let's remind ourselves of what we know so far. So far we know that the moles of our acid are that 9.7 times 10 to the negative 4. And we know the volume of that acid that we started with. We started with 25 milliliters of it. Right? So, remembering that we need to make sure to convert to liters for this formula to work properly, I'm going to divide by 1,000. And that moves my decimal place back 3 spaces. So now I have a value that's in liters. So I'm ready to go. I know my concentration, or I don't know my concentration, but I do know the number of moles that were involved in the reaction. I also know the volume that was reacted. And so substituting those values into the formula, we can see that if I have moles divided by liters, then the final result that I get as a result of manipulating those dimensions will be in units of moles per liter. So calculating that out, I am getting a concentration of 0.039 moles per liter. Remember that I need to do my unit analysis. I have 2 significant digits because both of the measurements used in the calculation had 2 significant digits. So finally, just writing my final response, therefore, the concentration, and I can actually use these square brackets, is 0.039 moles per liter. Alternatively, I could have written that in scientific notation, and that would be appropriate as well. So I'll be posting some questions for you to practice online. Make sure that you have the opportunity, take the opportunity today to work through those, and that will give us more time tomorrow to answer questions and to complete the lab on qualitative analysis.